coast flight phase for the third stage.
Now the engine is shut down.
Shut down.
厦门先动正常，调节标正常。
10 minutes.
The lunar and planetary probes launched by the Soviet Union used to have a lengthy coast phase, and they used liquid propellants. And the problem appeared to be that the propellants were just flying around loose inside the tank. And when they turned on the pumps again to restart the engine, they didn't necessarily find any propellant.
You mean the propellants have been escaped?
No, the propellant was floating free inside the tank. It was not settled.
厦门先
And
动正常，调
there
节
is
标正常。
an idea that's called an ullage rocket. An ullage rocket is a small rocket engine that is fired just to provide enough force to settle the fuel in the tank, so that when the pumps restart, they will actually draw the propellant in.
Why do we need a cold phase like this in the first place?
It's just a matter of looking at the geometry of the mission. There will be an optimum place to depart from low Earth orbit, and that is not necessarily at the same place where the second stage burns out. In the case of the Soviet Union, they required actually a change of direction, a dogleg maneuver, where they changed the plane of their orbit. And
They have to change the plane of their orbit? Is
Yes,
it because of their latitude?
Their engine burned out fairly early in the flight, and they reached orbital speed, but then they couldn't depart in the plane of the solar system, in the plane of the ecliptic, until they reached that plane. Then they restarted the engines, or tried to. They had considerable difficulty doing it.
So just now we have been talking about the propellants. Will we be able in the future to have more choices of propellants, make our rockets powerful and make the journey faster?
If you're talking about chemical propellants, hydrogen and oxygen cannot be beaten. There's nothing that will do better.
And what about other sources other than chemical
There are many
propellant?
other kinds of propulsion, some of which are much more efficient than chemical propulsion, but they don't work significantly well inside the atmosphere because they have, although they're very efficient, they have low thrust levels, not sufficient to lift you against gravity and get out of the atmosphere.
So currently this is the best technology we have.
For chemical propulsion, yes.
长江5号发现目标。长江5号发现目
Well,
标。
obviously there is a tracking ship has monitored and tracked the flight of the rocket, which is now in this cold phase, which will last about 10 minutes. And then they will ignite the rocket again.
Right. About 10 minutes left. The rocket will bring the lunar probe very near the perigee altitude. Then the third stage engine start again to push the lunar probe into the LTO orbit.
The third stage rocket will be ignited to push the orbiter into its transfer orbit by then.
Right.
And that's about in 5 minutes, 10 minutes?
It's about 5 minutes.
In 5 minutes, we're about to see Chang'e-2 being moved into the Moon-Earth transfer orbit when the third stage rocket is ignited. So in the future, when China have its fourth launch pad in Hainan, which is near the equator, do we have a different options of sending a spacecraft,
长江5号跟踪正常。
different trajectory, or is simply less fuel?
They're not fundamentally different. The principal difference is that a given booster rocket will be able to deliver more payload to geosynchronous orbit or to the moon or to a planet.
And is there any new technologies being employed if we have something launched from the equator? No.
No.
Now it seems that the Chang'e-2 has been traveling above the Pacific Ocean, where it is tracked by command and control ships deployed earlier by China on the ocean.
长江5号跟踪正常，遥测信号正常。
So at the current stage, the command and control center don't have to send any signals to the rocket or the orbiter. It's just on its own.
So just during the powerful phase, the rocket powerful phase, we do not send any command up to the rocket or the satellite. Just after the separation.
Not until the third stage is ignited.
Not until the lunar probe separation from the launch vehicle.
Obviously, the flight time is 980 seconds. What you see here on the screen is the tracking stations on the ground. They include Xiamen and 2 tracking ships. So by when we can say the launch is a success?
So firstly,
the launch
the lunar probe mass separation from the launch vehicle, and we confirm the trajectory parameter is exactly the LTO parameter. We can say that successful launch.
When will the transfer orbit begin?
Just after the separation.
It's
the lunar.
In about 5 minutes?
Right.
As soon as the third stage fuel is exhausted and the engine shuts down.
So when the third stage of fuel is exhausted, then the probe is on its own to be transferred into the orbit to the moon.
Yes, and if the third stage were to remain attached to the payload, it would just travel along with it to the moon.
Will it? It's supposed to be separated from the payload.
It is supposed to be separated, but it's all, they both have the same speed, so they're both going to follow the same path.
So the lunar probe only have a data velocity about 0.5 meter per second, 0.5 meter per second. So the third stage and the probe will
travel along for a while.
Travel for 5 days
because
moon.
Of the momentum.
Right.
Yes, that empty rocket stage is going to the moon too.
But it won't hit the moon because it's just floating.
It is coasting.
Coasting. Well, this is a special coverage of the lunar probes. China's second lunar probe, Chang'e-2, to the moon. Now already 18 minutes have passed since the liftoff. According to our experts about the rocket, in about 2 to 3 minutes, we will see another important point. That is the third phase of the rocket will be ignited again, and then it will be the transfer orbit of the lunar orbiter Chang'e-2.
长江3号跟踪正常，遥测信号正常。长江3号跟踪正常，遥测信号正常，北京飞行正常。
So the second powerful phase for the third stage is around 2.5 minutes.
It lasts 2.5 minutes.
2.5 minutes.
You mean when the third stage is ignited?
So the flight altitude is about 118 kilometers.
Do we have a ratio of distribution of the propellants in different stages?
You mean
The propellants in the first stage, the second stage,
it's the same,
is the same.
right? Only
And if the composition is the same.
The proportion of fuel to oxidizer is the same, yes. The actual mass of fuel in each stage is roughly a factor 3 or 4 less than in the previous stage. Depends on the rocket and the mission.
you can see the ignition of the third stage,
You mean the ignition has already started?
and now seconds.
There it
Well,
is.
the ignition started,
Right.
so the cold phase is passed.
30.5，
The third stage, the ignition of the third stage has already started. That's a successful ignition. And that means we are about to embark on the Earth to Moon transfer orbit, which is one of the key points this time for this mission. That is until 2 minutes away, we will know whether or not the major mission of lunar orbiter Chang'e-2 is successful, because by then we will know it is on its trajectory or not.
Right.
So next action is the separation.
The separation from the rocket.
Right. It's very is a key element, a key point.
So when it separates from the rocket, then it's relying on itself for power. How different is this power from the rocket power when the orbiter or the spacecraft is on its
The
own?
spacecraft is relying on its own electrical power at this time. The only power it's getting from the booster is that the booster's pushing it.
Why don't we have booster all the time to have power? Why we have another source of power for the
It
spacecraft?
only takes a few minutes to use up all the fuel.
So we have to have a sustained way of power.
Yeah. There's also another principle, which is that if you have a chemical rocket engine in a low orbit around the Earth and you fire it very quickly, use all your fuel in 5 minutes, then you can produce a certain speed for the spacecraft. But if you burn the fuel very slowly, then what you're doing is you're spending a lot of the energy of that fuel lifting fuel to higher altitudes, and it's actually less efficient.
And
called
from
gravity
ground
loss.
to orbit, a lot of fuel will add a lot of weight, burden on the liftoff process
A
itself.
lot of fuel has to be spent lifting everything up to the top of the atmosphere. Yes.
So that is why the fuel has to be spent very quickly in the liftoff stage.
That's right.
And when it is on
Well-
the way to the outer space, it has to spend slowly.
If the thrust of the rocket is twice the weight of the rocket, then it will accelerate upward at 1 Earth gravity. Okay. On the other hand, if the thrust of the rocket is equal to the weight of the rocket, you can sit there and burn fuel forever and not even leave the ground. So there's a big advantage to burning the fuel quickly.
Yes, we are about to see that phase. That is the successful Earth to Moon transfer orbit, whether that works or not. Very soon the result will come out. So far, the Tracking and Control Center has been saying it is normal, it is as scheduled,